Morning, everybody. We welcome you all to our Multi-Medix webinar series on ultrasound quality assurance. This is the third of our webinars, and there's going to be four of them all together. And tonight we're going to be talking about ultrasound QA and baselining in particular. My name is Marilla Stevenson. I'm going to take you through a few administrative points first of all. If you can keep your cameras switched off during the webinar, then that helps with any lagging that there might be. There is going to be a question and answer session, and we're going to do that towards the end. So the final 10 minutes or so will be for questions. And if you can answer those through, ask those through the chat panel, that would be great. All the webinars are being recorded, including this one, and the recordings are available on the online knowledge portal from about midday tomorrow, midday UK time. And if you do happen to have any audio or technical issues during the webinar, I'm going to put my email address in the chat panel. Please do contact me. I will be watching out for emails coming in. But also, if you've got any questions in between the webinars as well, then you can use that email address in terms of trying to access the online portal or whatever it might be. Our presenters today are Darren Woolley and Dr. Nick Dudley again. Dr. Nick Dudley is an ultrasound physicist, and he has over 50 peer-reviewed papers, and he's contributed to ultrasound QA guidance both in the UK and Europe. And Darren Woolley has 25 years experience in maintaining and managing medical equipment. He's a leading authority on electronic probe testing and identifying counterfeit and unsafe probes. And he implemented the UK's first ISO 13485 certified ultrasound lab in the UK as well. So that's a little introduction to our presenters there. I just wanted to remind you all, because this is our third session, that why it was that we started off doing these webinars. We'd done a survey last summer asking hospitals if they were doing QA, if they were not doing QA, if they weren't doing QA, why weren't they doing QA? And the majority of answers came back that people either didn't have the time, or they didn't have the knowledge, or they weren't aware of what QA needed to happen. And we're almost coming to the end of our webinar series. So I hope that these webinars have started to provide you with some of the knowledge that some of you have may felt that you were missing, and also particularly in that final, the last webinar that we had, you've been able to see as well that some of the QA checks literally do take minutes to do. So as we did with the previous one, I'm going to just launch a poll. And the question I want to pose you is, in the last 7 days, and I'll even extend that to from the beginning of this webinar series, have you done any ultrasound user QA? Because I suspect many of you weren't doing any QA or some QA, or didn't even know that what you were doing was some QA. So we're just interested to know whether people have actually had a go, even if it's just downloading the book, having a chat with a colleague. I'll let the poll run a little bit longer just to see if anybody else has got an opportunity to answer. Okay, and I'm going to end it now. And I believe I can share the results. So actually, yeah, most people have been able to do some QA in the last 7 days. So that's really good, really good. That's great to hear. And in the next session, what we're planning to do is to bring all of this together so that you can really begin to implement a full program into the departments that you work in, to really use that final session as a springboard for your department to be able to put in place a full QA program. Not in the next 7 days necessarily, but over the coming months, right through to December, because we're fully aware that departments have been stretched beyond belief during the pandemic. So we want to use that final session as a way of being able to give you the tools to be able to go ahead and implement a QA program. And we're going to be joined as well by Jill Harrison from SCORE. She's the professional officer for ultrasound, and she's going to be talking about how an implementation of a QA program can be counted towards CPD as well. So it should be a really interesting session. Anyway, back to tonight. I'm going to hand you over now to Darren Woolley, Dr. Nick Dudley.
Hello, everybody.
Hello, everybody.
Thank you a lot. Just going to bring Nick into the frame. So let's get straight in with this one, Nick. So tell us about the purpose of baseline testing, please.
Yeah, so we've talked about routine testing. If you're going to do routine tests that need anything to compare with, then you have to do some baseline testing. So baselining should ideally be done when you do your acceptance testing, and you're going to do things like collect images of in-air uniformity tests, so that you've got something to compare with there, and do some measurements that you can compare the later sensitivity measurements, for example, with. So in the first stages of implementing QA, really you're focusing on the in-air reverberation uniformity and the very simple sensitivity measurement that we talked about before.
Great. And what other tests go beyond that as well then, Nick?
Yeah, there are another set of in-air tests that I used to do monthly and now only do annually. And those are for noise. They don't unearth many faults, but they're still worth doing periodically. There's a test for B mode noise, a test for spectral Doppler noise, and a test for color Doppler noise, because those are all processed in different channels. And they're very simple to do. I'm going to describe those in a bit more detail later on.
Great. Now, I think to get this right, Nick, setup's a really key factor when we do this.
Yeah, so I'm just going to share some slides with you now. So you can see from this slide how important QA settings are. The top image there is on clinical settings, and you can't really see any dropouts. And then with QA settings, you can see all these areas of dropout. So the setup is very important. I'm going to tell you a little bit about that and why. Just ignore the bits about phased array and multi-row arrays. They're covered in the QA manual. I'm going to concentrate on linear and curvilinear arrays because those are the most common. So I'll explain those. So we're looking at the in-air reverberation, and we want it to occupy a big portion of the display because we're going to measure it. But you have to make sure that you don't lose the ends of the array when you magnify it up. The focus is set close to the probe. And the reason for that is the closer to the probe you have it, the fewer elements are activated for each beam. So you've got more chance of seeing any dead elements. And we turn compounding, automatic image optimization, and real-time image processing off because these are all going to mask faults. I always like to start at the highest fundamental frequency, just to keep it simple, really. But you might need to change that as you go through your baseline testing. And I again start with the output maximum and TGC mid-range, just to try to keep things simple. So that's the basics of setting up. Darren, you've got a scanner there, so I think you can show us the steps that you go through in achieving those settings.
Yeah, Nick, I'll jump my screens over to a different camera. So I've got a Philips CX50 with me today. So it's got all the traditional console controls and settings. So we'll use this for demonstration. So I've got a fairly standard TV probe, and we've selected a standard obstetrics preset as a starting point. So just a typical preset. When it comes onto the user preset, it defaults to several settings. So for instance, we've got a depth of 8 centimeters and our focus is around 5. We've got harmonics on and it's operating at a general frequency which is mid-range for this particular probe. And it's got some of the processing and compounding turned on. So these are some of the features that Nick said we should do. So what I would firstly do is I would turn the harmonics off, so over here, and then I would adjust the control here to display the highest fundamental frequency. So on this machine, it will display the words res, and on this little graphic here, it'll tell us it's in res, and it's about 8 megahertz. I would then turn off processing and compounding, so X-res and so no CT. And then we would adjust the depth to make the air reverberation pattern occupy what Nick said, about 20 to 50% of the depth of the image. I think somewhere between 2 and 2.5. I'll leave it on 2 because it's probably easier to see on the webinar. Centimeters of depth. So you can see we've got a nice large representation of the air reverberation pattern. And then I'm just going to use the same control to adjust my focus up towards the face of the probe. And the shallowest this will go is 0.5 centimeter. And that's kind of the starting point with my gain turned up to maximum. So gain's gone up to 100 here. That's kind of my starting point to create a user QA preset. What I would typically do at this point, having frozen my image, I would use the preset control, which is here. And this would give me the option on the screen here to save this preset. If I just press that, it gives you the ability to create new, and you can name that accordingly. We would typically reference this particular probe model within that as part of the user process, and make that very accessible for the next step, which I think Nick's going to talk about a little bit next. Just bring that camera back. Nick, I'll bring you back in. There we go.
Okay, thank you, Darren. So Darren showed you the setup. I'm going to show you the actual tests. So here's one that was set up as Darren's just described. And the first test is to measure the depth of the deepest reverberation. Now, this is an example where I'm not too happy with it because this last reverberation isn't too clear. So the next part of setting up is to get an image where you're quite happy that you're going to be measuring the same thing every time you do it. So on this image, I would perhaps turn the gain down a little bit so that the next reverberation up becomes the last one. And if that's bright enough, then I'd stick with that. Other things you can change that might help other frequency. But anything that's going to be complicated to reset, I wouldn't fiddle with. So mainly the gain and the frequency. So here's one that I'm quite happy with. The deepest reverberation there is reasonably bright, and I'm pretty confident that anybody would get the same measurement there. And in practice, people actually do seem to agree quite well on this measurement. So we measure the depth of that deepest reverberation and record that depth, in this case 5.6 millimeters as our baseline. If that reverberation disappears or another one appears, the test has been failed. So the tolerance on this measurement has to be less than the distance to the next reverberation up. So I generally record as the tolerance half the distance to the next reverberation. And this isn't the most sensitive test because it depends on the brightness of this last reverberation. So there's an additional step. Here's one for a curved array, and you can see the measurement again here of the deepest reverberation. The additional step in this test is to turn the gain down until this last reverberation just disappears. So the point where it disappears, and if you turn it up again, it comes back like this. And then you record this gain as the reverberation threshold. And this is a more sensitive assessment of the probe. So there are some other tests that I mentioned you could do. So this is the basic test when you're first setting up QA. Once you've got the QA program established, then you can start looking at noise. I do this test annually. So here we are in B mode. can see noise in the image here. And if I turn the gain down gradually, you can see the noise is still there, and then it disappears. And at the point that it disappears, I'm going to record the gain, and that's the noise threshold. So that's a measure of the noise in the system. From experience, I put a tolerance on that of plus or minus 4 gain increments. And from some review of results, that does actually seem to detect faults and not produce a load of false positives. And then there's a similar test for spectral Doppler. Here you see the Doppler noise with the gain turned up high. Turn the gain down gradually and it disappears. Record the gain, that's the Doppler noise threshold. And then similarly for color, if you push the color box down to the bottom of the screen, turn the gain up, you'll see a lot of noise. Gradually turn the gain down till it disappears. Record the gain, and that's the color noise threshold. And as an annual test, I think these are quite useful. All of the noise tests, I put plus or minus 4. Oh, actually, plus or minus 4 on the B mode noise, plus or minus 2 on the Doppler and color noise, because they tend to be a bit more stable. So those are the basic tests.
So Nick, is there a place in our QA system for test objects and phantoms?
Yeah, there is. Ideally, coming back to the slides, if you get a sensitivity result by the method I've just described out of tolerance, you've got to manage that result somehow. And the best way to do that is to either measure the penetration in a phantom, which is just the depth where speckle disappears, or to measure the grey level in a phantom by putting a region of interest in something like ImageJ, which is free software, very easy to use, and plotting the grey levels. These are more clinically relevant measures of sensitivity. So I measure the average grey level from this curve from baseline to an individual measurement, and I would put a tolerance on that of plus or minus 10%. And that helps you to assess the clinical impact of any changes in sensitivity. If you've got a phantom, then you might as well take some images of the phantom, the other targets in the phantom, just to give you something to compare with in future. So if you took some images on a normal clinical setting of the different types of targets and compare them, if you ever suspect a fault, just a visual comparison can give you an indication of whether it's going to be clinically significant or not. So that's the place for phantoms if you got one. It's also worth mentioning that baseline testing's something that ideally you should do together with acceptance testing. And at that point, if you've got phantoms, then you can look at things like accuracy as well. But these are all things that you can implement in the later stages of implementing the QA program. You don't have to wait till you get a phantom to do the most basic tests. Excuse me, Darren, you've used the QA manual from scratch to set up user QA testing for customers. How did you find that experience, and what did the customers think about it?
Yes, Nick. Strangely enough, I've actually been doing some of that today as well. But by look of the diary and the appointments, I found the setting with the baseline, Nick, quite straightforward, but time consuming, as I'm sure you'll agree, because you've done plenty of this, and a great attention to details required just to make sure I got all of my settings correctly articulated and recorded my presets and saved them on the systems. So I think good attention to detail and time is important. What the feedback we've had from the users who have been using the system and the presets that we've used at baseline in is that They really like the simplicity of being able to very quickly access the user QA preset, very quickly and easily enact a series of tests that gives them a lot of confidence. And so the overriding feedback we've had, Nick, is that the users are very happy and they've become much more confident that their system and probes are performing as they should. But also, I think they've become a bit empowered on understanding, starting to recognize when things aren't correct. And I think they've embedded it into their day-to-day and their week and month-on-month operation of their imaging department quite seamlessly, actually. So I'm really pleased for the people that we've been working with quite closely that they've given us that feedback. And testament to you, Nick, because I know you put a lot of hard work and experience into bringing the system together to make it as easy as possible. Yeah,
that's really interesting. My experience with sonographers where I work is that once they've started doing user QA, they actually report faults when they're not doing QA.
Yes.
So, you know, they do the formal test monthly, but they actually report faults in between because they know what they're looking for now. So yeah, it is empowering, I think.
Great. Well, Nick, I think we've kind of hit our time limit for, but perfectly actually. So well done. Thank you everyone for listening. And I know Marilla's going to join us again to allow us to have some questions put together and just remind us about what's happening on the next webinar.
Okay, thank you. That was brilliant. Just before we get into some of the questions that have come up in the chat panel, I just want to mention what next time's session is going to be about. As I said, we're going to be joined by Jill Harrison from SCORE, and she's going to be talking about implementing a QA program with the point of view of how it overlaps and helps getting CPD credit. But it's also just an opportunity for those people who've been watching the recordings, perhaps haven't been watching live, or if you've been watching live, there may well have been times when you think, oh, you know, I have watched the webinar and I've watched the recording, but I'd still like you to recap something, or there was something I didn't quite understand, or there may be a way that your ultrasound department works. It's something particular to your hospital, your clinic, and you're wondering how QA might work in that particular environment. So it's asking all those sorts of questions so that you can, there's no blockers for you to go out and start implementing some QA. So please send those questions in between now and next time's session. Obviously, you're free to put them in the chat panel next time as well. But it would give us an idea as well as to what areas you might want us to recap on if necessary as well. The other thing that lots of people have been asking about in between the webinars is the manual. So I just wanted to mention, oh, look at that. My glamorous assistant is holding up a copy of it right there. So the manual is available on our online knowledge portal as a PDF to download. Hard copies were sent out to hospitals at the back end of last year. If you're having problems getting a copy, then please do email me. I'll put my email address in the chat panel earlier on, you know, we can deal with that. But a PDF is available on the online portal. I get some people saying, calling it, you know, the physics book, and that they're worried, you know, because they need to brush up on their physics. But it's actually a step-by-step, easy to follow guide. It's got quick guides in there. It's got diagrams in there. You don't necessarily have to go and brush up on your physics at all. And if you actually just want to be shown what to do, the book has QR codes. So you just scan the QR code and it'll take you to a video which demonstrates what that particular part of the book is actually showing you as well. So I just wanted to talk a little bit about that because lots of people have been asking questions about that. So BMIS, IPEM, ultrasound bodies all around the world all agree that ultrasound QA is mandatory and it should be a crucial part of patient safeguarding. And I think we've mentioned that in all the webinars. But as Darren was saying, the word that comes through more than anything when people have implemented QA is that they feel empowered. They really do, feel a lot of confidence in their system. It's something we really want to sort of encourage you all, therefore, to do. That feeling of confidence and empowerment comes from being able to do your QA. Right, we've had a few questions in the chat panel and a few questions sent to us in advance. I'll deal with the questions that were sent in advance. When our probes are moved from system to system, what should we do?
Good question, Barilla, because I know from experience, and so does Nick, it happens a lot, but I'll let Nick explain what's a good way to manage that.
Yeah, the physical inspection of the probe and the uniformity assessment can be done on any scanner, so long as you've either got the user QA preset or you know how to set the settings to look at uniformity. The sensitivity measurements and any other type of measurement really needs to be done on the scanner that the probe was first tested on. We've got two options. One is when you do quantitative tests, take all the probes back to their original scanners. The second option is baseline the probes on every scanner that they might be used on. And then it doesn't matter where they are, you can still test them. And which one of those solutions works is going to depend on your local circumstances.
Thanks, Nick.
Okay. Then the first question in the chat panel we've got is from Henry Zong, and I recognise this name. Just scroll down a little bit. I believe, yeah. Last year, Multi-Medix sent out pin badges, rainbow probe pin badges to sonographers as a sort of thank you for everything they've done in the pandemic. And Mr. Zong lives in Cameroon and waited 6 months for his badges to arrive. That's why I remember the name. He waited the longest period of time of anyone, and they finally did arrive. And I think he's got his second batch now as well. So I really remember your name. It's lovely to have you on our webinar. Henry's question is, I've been working as a sonographer in rural Cameroon for about 10 years. We don't have a QA system. Where do I start?
Well, Henry, thanks very much for joining us. I'm really pleased that you're interested in QA. You can start with very simple things. If you do a physical inspection of the equipment, looking for cracks and defects, and have a look at the in-air uniformity, looking for any dark axial banding or blurring of the in-air reverberation pattern, that's going to pick up, if you do it well, more than 90% of faults. So you don't have to have any complicated equipment or any expert knowledge really, other than your sonography skills, to be able to do effective QA. So you could go into your department now and start doing QA just with those very simple things.
So Nick, I think we touched on that on the first webinar. So if Henry didn't see that, watching that again would be a good idea. And we referenced some of the material in the book, whether it's in electronic format or the hard copy. A lot of useful information's available to help that starting point as well, isn't it, Nick? Yes.
Yeah.
Yeah, brilliant. And if you need need to ask any further questions, please do. Please do. We also have a question from Khalida on any advice on how best to document the results. Is there a pro forma, if that's the correct terminology, that can be used?
Hi, Khalida. Thanks for your question. Very good question. You have to keep records, otherwise you may as well not have done it. In the manual, I don't know if you can see that very well. We've actually
you can see it, yeah,
provided some forms for all of the tests. So you could either just use these straight from the manual, or you could make your own based on these if you want to do something slightly different. But it's all there. The whole idea of the manual is you can just pick it up and do it. There should be no need for any setting up or anything other than the baseline setting that we've described today. So it's all there in the manual for you.
Brilliant. Okay.
Right. Thank you, Nick.
I think that's all the questions we've got, unless anybody else has got any questions they want to put into the chat panel. Just give it another couple of minutes. Yeah. Just to add to that, Khalida, I think some hospital departments have taken those pro formas and then just put them on the shared drive. You know, they've created an Excel spreadsheet and put them on the shared drive for everyone to use and be able to access. So you can use them like that as well. Good. Okay. Well, that is 30 minutes on the dot. So we promised that they would be bite-sized 30-minute webinars. So we've just finished on time. Thank you very much for attending this evening. Thank you very much for your questions. If you stay on, Henry, we can answer some more questions for you in the chat panel if you want. But I understand the rest of you may well need to go now. So thank you very much for attending. Hope to see you next week.